Welcome to this case study on selection of permanent magnets on the design of permanent magnet mission. We are all familiar about permanent magnets. They have the ability to produce magnetic flux without any winding or without any excitation. And we would have heard about different types of magnets. Like from the childhood, we would have heard this term horseshoe magnet, that is a permanent magnet. And these permanent magnets play a very important role in in MEMS, in automation applications, in high torque applications, microwave applications, computer peripheral, in office equipments, in transportation. All these areas, permanent magnets play a very vital role. And if you take up the characteristics of permanent magnet, uh, it should have high flux density. We should think about the recoil permeability of the magnet, the corrosion resistance, electrical resistivity, then low magnetizing field, physical strength, demagnetization curve, etc. All those factors have to be considered for the they have to be they are the characteristics of permanent magnet. And the manufacturing process of these permanent magnets also, it plays a vital role. And if you see in the slide, whatever shaded area that you have, that shows the positivity and the negativity. And like if you take up the manufacturing process, you have a five manufacturing process. Sintering process is used for rare earth and alnicos. And if you see, the positivity is it gives you the maximum output, and the main negativity is it is very brittle. In the case of pressure bonding, like you can go with greater volumetric loading, but if you see, the negativity is very high in the case of pressure bonding. In the case of injection molding, like you have a lot of flexibilities, right, in shaping the magnet. You can come out with complex geometries. It could be relatively very tough. The assembling cost is going to be very low. But the main thing is it is going to have lower BH max. That is the main drawback. In casting technology also, right, it is similar to it. The mechanical resistance is going to be very low. In the case of calendering and extruding process, the main drawback is lower BH max, but you can come out with any complex geometries in the case of calendering and extruding techniques. And if you take up the use of permanent magnets, we need not go with any electromagnetic coil arrangement. You can get a very high torque density is possible, or high output power density is also possible. You can go with better dynamic performance. Then the maintenance and everything is going to be very simple. Uh, so that's the main use of permanent magnets. And if you take up the grades of magnets, if you take up alnico is alloy of aluminium, nickel, and cobalt. You have grade numbers as 1, 2, 3, 5, 6, 8, and 9. If you go with SMCO, that is samarium cobalt, the grade number is 16, 18, 20, 22, 24, 26, 28, 30, and 32. You have it in even series from 16 to 32. If you go with neodymium magnet, like a magnet with a high flux density, if you see this one, it is graded from N35 to N52, N35, N45, N38, 42, N48, N52. You can see the field strength here, right? So field strength based on the color shading, you can see it. So higher N52 has got a higher field strength compared to N35. That is the benefit of using neodymium. And if you go with the BH loop, we have to take up this second quadrant operation. That is, when you try to demagnetize the magnet, how it responds, right? So it is not the magnetizing loop that we have to consider. We have to consider the demagnetizing loop. And if you see this one, Br is a factor of coercivity, like coercivity, and here this HCI also has to be considered. And if you take up the sizes, the size and the shape, it all depends upon the type of magnet that we use, the grade of the magnet that we use. And if you take up the characteristics, right, like if you take up the characteristics, these three factors, your BR value, HC value, and your remanence flux density, recoil ability, and BH max, all those three factors have to be considered, right? They have to be considered while studying the characteristics. And if you take up the efficiency, also efficiency is going to be higher, and you'll have only a slight variation in the efficiency level, and the torque that can be achieved also, it is going to be very higher. And this is the output characteristic, output power versus torque angle. So output power versus torque angle can be very high in the case for various angles. If you see the output power, it varies for one cycle, it varies. And here also, if you see the magnetization curve for one loop, for both motoring as well as for generating, you get it for different magnets also. And if you see the torque angle versus efficiency also, as the torque angle is very high, the efficiency also is very high. So from all these things, we can we can predict that, we can say that the grade of permanent magnet that is used has effect. Though the variation is very small, but it has a vital effect on the electrical characteristics and the mechanical characteristics. Thank you.